Okay, hi everyone, I'm here with your 423 lesson. It is called How Can I Compare Them? Enlargement and Reduction Ratios. In the past few lessons, you enlarged and reduced images while preserving their shapes. By doing so, you created similar figures. You learned, for example, that to enlarge a shape to 300% of the original, you multiplied the length of each side by 3. If you want to compare side lengths of similar figures, one way to do so is by using ratios. A ratio compares lengths by dividing. In this lesson, you will learn about using ratios to determine whether enlargements or reductions were done correctly. As you work with your team, use the questions below to help start your discussions. How does the shape change? What are we comparing? And how can we describe the relationship? If we're looking at problem 463 to start, it says Andrew, Barb, Carlos, and Dolores were looking at the similar triangles at right. Similar in this context means that the triangles have the same shape, but they are different sizes. I'm confused, said Carlos. Is the triangle on the right an enlargement of the triangle on the left, or is the triangle on the left a reduction of the triangle on the right? Part A. Work with your team to find a way to describe the relationship between the lengths of the sides of these two triangles. Think about how each triangle might have been created from the other one. Be prepared to share your ideas with the class. Go ahead and pause your video and answer question A. Okay, if you're back with me, that means you have answered question part A. So let's talk about this. So if you were saying, if we were talking about the right-hand triangle, you would say, or hopefully you said something along the lines of the right-hand triangle is 2.5 times as big as the left triangle. So in other words, you could have said for every 2 grid units in the left-hand triangle, it becomes 5 units in the right-hand triangle. So it's 2.5 times as big. B says, Hey, Barb, said, I just learned about ratios from my sister. She told me that ratios are another way to compare quantities like the dimensions of these triangles. We could compare these triangles by setting up the ratio of 4 units to 10 units. We can write it in these ways. These ways over here. 4 to 10, 4 over 10, 4 to 10. Carlos wondered, but wait, why wouldn't the ratio be 6 to 15? 1. Where did Barb and Carlos get the numbers that they are using in their ratios? What are they comparing? Go ahead and pause that and answer. Okay, if you're back with me, you've answered part 1. You should have said that Barb got her ratio from comparing bases. Carlos got his ratio from comparing heights. So if you look, bases and height. So our bases are down here, our heights are over here. So Barb got hers from the bases, Carlos got his from the heights. Part 2 of problem B says, whose ratio is correct? How do you know? Go ahead and pause and answer this. Okay, if you're back with me, you should have answered this. You should have said that both ratios are correct. Okay, or they are the same. And then you needed to explain. Part 3 says, what are some other ratios that represent the same relationship as 4 to 10? Work with your team to find at least 3 other ratios and be prepared to share them with the class. So go ahead and pause the video and answer part 3. Okay, if you're back with me, we're going to save that part and talk about it in class. Part C says, Dolores was confused and wondered, why isn't the ratio 10:4? What do you think? Go ahead and pause the video. Okay, if you're back with me, that means you've answered this, and we're going to have that discussion in class, so we're going to save it. Moving on to 464. 464 says, Andrew had an idea. He drew the diagram at right and described the relationship between the triangles with the ratio 2:5. Is the ratio 2:5 the same as Barb's ratio of 4:10? Why or why not? Go ahead and pause and answer part A. You should have said that yes, it is the same as Barb's ratio, because every 2 units in the smaller triangle turns into 5 units in the enlargement. So it's saying 2 units turns into 5 is what that's saying. This whole length of the small is 4, then the whole length of the bigger side is 10. B says, Dolores drew the heights of the 2 triangles as shown at right. How could she see, and it continues on the next page, the ratio of 2:5 in this diagram? Discuss this with your team and be prepared to explain your ideas to the class. So go ahead and pause that and answer. Okay, if you're back with me, you've answered this. So hopefully, if we knew that this whole side length was 6, we knew that it would be broken down into 3 2s. So if it's broken down into 3 2s, we would have 5, 5, and 5, which then makes this whole length 15, which if you look, that matches the diagram that was on the previous page down here. So you could have also explained that in words. There are 3 2s in the height of 6, and 3 5s in the height of 15. So each 2 units of height in the smaller triangle turns into 5 units of height in the bigger triangle. So 465 says, you may remember that a quadrilateral is a 4-sided figure. There are many different kinds of quadrilaterals. On graph paper, draw a quadrilateral with one side that is 12 units long and another side that is 9 units long. Then reduce your quadrilateral so that the ratio of sides of new to original is 2:3. So to finish up the video, you are going to finish up the video in the lesson, you're going to finish problem 465. Make sure that you upload pictures of your work, that's your note packets and your graph paper for your problem for 465. As always, if you have any questions, please email me. Once you're done with 465, you have completed the lesson. So again, make sure you upload those pictures.